Hello everybody and welcome to another geometry video. Today we're taking a look at section 1.5, which is all about how to measure and construct an angle. So when we're talking about angles, folks, we're talking about a very specific type of structure. Most of us know what an angle generally looks like. An angle will look something like this. You've got these two lines here, like so. So what really makes up an angle? Well, an angle is made up of two different rays. You see that there's a ray that goes up here, and we've got a ray that goes through here. I will label these points C, A, and B, for instance. So it is the set of points consisting of two rays with the same endpoint. Consisting of two rays with the same endpoint. So we've got ray AC and ray AB. The endpoint that we're talking about here is called the vertex of the angle. So the vertex is going to be the endpoint of an angle, very important. And the rays themselves are going to be the sides of the angle. Again, these are the rays of an angle. When we're talking about angles, angles also have an interior portion and an exterior portion. So the interior is all the space in between these two rays. Meanwhile, the exterior is everything that's outside of the angle. So this whole portion here is the exterior of the angle. The interior is the region containing all the points between an angle's sides. While the exterior is the region containing all the points outside the angle, like so. Next, I want to talk a little bit about the measure of an angle. So this is where things get a little bit unique. Angles, just like line segments, have a measure. But we have a problem. On an angle, these arrows go on and on and on forever. So when we talk about the measure of an angle, we're not talking about how long its rays are, because those are infinite. We're talking about how wide or how far apart our two rays are. We will talk about this again in just a moment, but the measure of an angle is just want to make sure we can see it, the difference between real numbers measured on a protractor, this fancy tool right here. So let's take a look at the bottom of the page and talk about how we name angles. We actually have a ton of different ways that we can name an angle. There are 3 main ones. The first way is to use the vertex. If you've got just one angle by itself, the easiest way to name it is going to be based off of the vertex. So this angle here, I could just call it angle A. Another way to do it is to use 3 points that are across the angle, with the vertex always being the middle of the points. So like I could name this angle CAB because that's the direction it goes. It goes from point C over to point A and then right to point B. I could name it backwards. I could call it BAC because it goes from B to A to C. But I could not call it ABC, for instance, because while the angle goes from A to B, the angle just keeps going in this direction. It doesn't suddenly jump over to point C. So when you're naming an angle, always make the vertex the center of your name. Finally, you could also just give the angle a number. This is much less common, but we'll see it in some examples. So like I gave this angle the number 1. So we can just call this angle 1. Remember how when we were talking about line segments, there was a difference between this and this? This refers to the actual figure, whereas this refers to the length of that figure. Well, it's the same with angles. If I give you angle A, I want to show you an actual angle. It's a diagram. But if I ever wanted the measurement of an angle, I would mark it as M angle A. That'll be the measure of the angle, or how big it is. Just make sure we keep this difference in mind as we move forward. Speaking of moving forward, let's flip the page. So, let's talk about some names for these angles. I'm going to do example A here, and then I want you to do examples B and C. It asks us to write 3 names for the below angles. So looking at this first angle here, the angle for part A, I notice that it's given 3 letters, B, O, and G. So the first way we can name it is just based off of the vertex, angle O. The second one is to go in order with our letters one direction, so B, then O, then G. And then finally, we could also go backwards. Instead of going bog, we can go gob, G-O-B. And there we go. Pause the video and see if you can get parts B and C. How do we do? Technically, B and C have 4 different names, but I only need you to write down 3 of them. So these are the options you can choose from. When we're talking about angles, there are 4 main types of angles that we can talk about. All the types of angles depend on how far open those angles are. So if you have an angle like this, that is just a little bit open, there's a little bit of an interior, we call it an acute angle. Acute angles are always between 0 degrees and 90 degrees. That's their measure. Right angles measure exactly 90 degrees. To show that they're 90 degrees, we will usually mark their corners with a square on the interior of the angle. That tells everyone who looks at it, hey, this is supposed to be a perfect right angle. Once you open up past a right angle, you get an obtuse angle. Obtuse angles are bigger than 90 degrees, so they're bigger than right angles, but they're still less than 180 degrees. They still look like an angle. Finally, we have a straight angle. Straight angles measure exactly 180 degrees. And what you'll notice is it looks just like a straight line. There is one more type of angle that we're not going to talk about today called a reflex angle. That's what happens when you bend a straight angle and have it keep going past 180. We're not talking about those today because they just look like obtuse angles for the most part. When we are measuring an angle, here is how it is done. So let's say I wanted to measure this acute angle. Step one is we're going to take our protractor. I'm going to zoom in here. And on every protractor, there's usually going to be a dot or some location where you want to place your protractor. We are going to place that dot right on our vertex. That's the first little bit here. So I've placed it right on the vertex. Step two is most protractors will also have this straight line here that leads to the numbers 180 on one side and 0 on the other. Tilt your protractor, still keeping the vertex as the middle, until you see the line matching up with your ray. In fact, mine needs a little bit of adjusting. That's about right. So now this ray matches up perfectly with this line. Normally, to read an angle from here, you would try and see where this arrow goes through. It's a little tough to see though because this arrow is too short. If you ever deal with an arrow that is too short and doesn't reach the end of your protractor, you are allowed to use the straight edge of this protractor to extend the line out to be even longer. So here we go. I am just literally extending my line up a little bit to make it easier to see. Now, when I place my protractor down and adjust it, I see here that this line goes straight through the marking between 40 and 50, 130 and 140. This means the measure of our angle is either going to be 45 degrees or 135 degrees. But how do you know which one to use? Well, it's based off the type of angle. Since we're dealing with an acute angle, we know that it has to be less than 90. So if your angle is acute, you use the smaller set of numbers. If your angle is obtuse, you will use the bigger set of numbers. So this is a 45-degree acute angle. Meanwhile, if I wanted to measure the obtuse angle down here, we would do all the same steps, and I will spoil this one and let you know, this one will end up being 135 degrees. Again, you might have to extend out your line to make it work. What I want you to do is I want you to find the measure of each angle and classify each angle. So I'm going to do example A here just to show you what we're looking for, and then you'll do example B. Step one is we want to measure this angle. So I'm placing my protractor down perfectly where it should be, and I'm noticing that this arrow seems to go right through one line past 20. So I'm going to call this a 21-degree angle. Down here we have some blanks to fill in. The measure of angle blank is about blank, so the angle is blank. In this first spot, since we're talking about the measure of angle blank, we know this is where the name of the angle should go. I'm going to call it angle CAT. So the measure of angle CAT we said was about 21 degrees. So we would call this angle acute. Pause the video and give B a shot. Hopefully you've given B a good look at. B looks like it should be about a right angle, and it is close, but not exactly. Notice that my protractor is not going to actually fit here. So I can extend my line segment out a little bit, like so. There we go, that should be long enough. Now when I place it back down, we see that the line we created goes right through 2 marks past 90. So is this going to be 92 or is it going to be 88? Well, this angle looks to be obtuse. It looks like it's a little bit bigger than 90 degrees. So we'll use the big numbers down here. 92 degrees is the measure of this angle. So the measure of angle DOG is about 92 degrees. So the angle is obtuse, like so. Very nice. Let's flip over to the next page. Oh, sorry, let's actually flip back to our definitions. I'm sorry, I realized we never finished those. All right. Next up, we want to talk about congruent angles. Congruent angles are pretty self-explanatory. It's two angles who are congruent. To mark off congruent angles, two angles that have the same measurement, we use a small arc in the corner of the angles. So these two would be congruent. Something that wouldn't be congruent is if you saw a different mark being used on the angle. For instance, a double arc. When we talk about congruent angles, we are talking about two angles, that's the short for angles, that have the same measure. Okay, that's congruent angles. Let's talk about the angle addition postulate. Now this postulate, I want to warn you, has a very strange definition. We're going to fill in this strange definition, and then we are going to talk about it. So, the angle addition postulate says, if P is in the interior of angle RST, then the following is true. The measure of angle RST equals the measure of angle RSP plus the measure of angle PST. What a crazy definition this one is. So let's see an example of what we're talking about here. It goes like this. We're starting off with an angle, and I want to name this angle RST. So R will go up here, S will go right here, T will go right here. I'm in fact going to color this angle in purple because in our equation, that's what we used to represent it. It was a purple angle. But something changes. We add a point P somewhere on the interior. I'm going to put it right here. This is going to be point P. The idea, folks, is this. If I connect S to P, making another ray, what I've just done is I've split my angle into two different angles. We still have our big angle, RST. We have this top angle, RSP, and then we have this bottom angle, PST. And the rule is this. Angle RSP, which I'm going to mark off with two blue arcs here, plus this smaller angle, PST, which I'm going to mark off with 3 just to show they're possibly different, will add together to make the big angle, RST. In short, two smaller angles can combine by adding their measures to make one big RST angle. The final definition here we have is of an angle bisector. We've already worked on how to make an angle bisector using constructions, so we should know about what this generally means. However, the rule is as follows. An angle bisector is something that cuts an angle exactly in half, making two congruent angles. So once again, an angle bisector is going to be a ray that divides an angle into two congruent angles. So when we flip the page over to page 3, or not page 3, sorry, this is page 14, page 3 of our notes for today, we can see that we will be using the angle addition postulate and the definition of an angle bisector to help us with these problems. Let's start with 3. The backyard of a house is illuminated by a single light fixture that has 2 bulbs, kind of like what's shown here. Together, they illuminate an angle of 147 degrees. If the angle illuminated by the right bulb is 56 degrees, what's the area illuminated by the left bulb? And we have to draw our own diagram. So, let's take a look and see what we can do. First, we have to sketch our own diagram. So I'm going to sketch sort of this light fixture simplified. I'm going to give it a bulb over on this side, like so. I'm going to give it a bulb over on this side, like so. The idea is we have 2 different lights that are shining here. We have one of our lights that's shining out like this, and one of our lights that is shining out like this. If the angle shown up by the right bulb is 56 degrees, and we know that the entire angle shown is 147 degrees, this would be 147 degrees, how wide should the green angle be? Well, according to the angle addition postulate, our big angle, 147, is going to just be made up of these 2 smaller angles added together, x plus 56 degrees. So really, we just need to subtract 56 from 147. 147 minus 56 gives us 91 degrees. So 91 is our answer. Notice that when we sketched our diagram, this does not look like a 91 degree angle. This looks super acute. But when you're sketching your own diagram, it doesn't need to be perfectly accurate. I mean, we don't know the answer to the problem yet, so it wouldn't make sense for it to be perfectly accurate. A diagram sketch is just used to help us conceptualize a problem, not to be perfectly accurate. Now we've moved on to exercise 4. And exercise 4 is tricky. There are 6 problems which start increasing in difficulty as we go through. I do want you to pause the video here to try these ones out. And then I am going to be talking about each and every one of them. So pause the video here and see how you do. All right, folks. Hopefully you've tried all these out. I'm going to show you all the answers so that you can skip one of the explanations if you already understand it or got the right answer. So here are all the answers. A is 132, D is 64, B is 15, E is 56, C is 130, and F is 90. I'm going to start off with example A and sort of work my way through from left to right. So in example A, we have the following. We have an angle here called ABC. And according to the problem, ABC is actually what we're trying to find. It says to find ABC. So we're looking for the entire angle. Now let's start with the information they give us. They tell us the measure of ABD. ABD goes from A to B to D. So it's this blue angle. This one, it says, is 75 degrees. So I will underline that in blue so we know what we're talking about. DBC is 57 degrees. So DBC goes from D to B to C. It's this one right here. So that's 57 degrees. The angle addition postulate tells us that the measure of angle ABC, the big angle, is just going to be the measures of the two smaller angles added together. So we can just substitute here. The measure of angle ABC equals, well, ABD was 75 degrees. DBC was 57 degrees. 75 plus 57 is going to give us 132. In the next one, we're asked to find the measure of angle QST. QST is going to be this smaller angle down here. And all we're given is the measure of RSQ, which is this angle here. We're told that this is 26 degrees. Normally, we would need to know what the entire angle is, because, according to the angle addition postulate, the measure of angle RST is going to equal the measure of angle RSQ plus the measure of angle QST. But we do actually know how big the whole angle is because there's a special marking in the corner. That marking right there tells us that RST is a right angle, which means it'll be 90 degrees. So 90 degrees equals RSQ was 26 degrees plus the measure of QST, which we're trying to find. So to find QST, we can just subtract 26 from both sides. 90 minus 26 gives us 64. Part B is extremely quick, to the point where I don't even need to write stuff down. Why? Because we are told that ray FG bisects angle NFH. This ray bisects the angle. It cuts the angle in half such that both halves are the exact same measure. So if we're told that angle NFG is 15 degrees, that's going to be this one right here, this tiny angle. This is 15 degrees, and it's congruent to the other side, which is what we're looking for, HFG. Then HFG also has to be 15 degrees. Bisecting means that it's the same on either side. So if the top angle is 15, the bottom angle is 15. E was a bit tricky. We're given 3 measurements here. Firstly, we are told that the measure of angle RWV is 2x plus 10. Thankfully, this one's already even labeled for us, so it makes it a little easier. RWL is 145 degrees. So RWL is actually going to be this entire big angle right here in red. Finally, VWL is 4x minus 3, where VWL is this angle right here that goes from V to W to L. So we need to figure out how to set up an equation for this. In short, the measure of the big angle, according to the angle addition postulate, is going to equal the measures of the two smaller angles put together, RWV plus VWL. RWL we already mentioned. RWL, ended up being 145 degrees. What about the others? RWV is 2x plus 10. So we'll substitute that in there. And VWL is 4x minus 3. So this is going to be an equation that we have to solve. When we combine like terms here, we will get 145 equals 2x plus 4x makes 6x. 10 minus 3 is 7. So there we go. And now it's just solving a linear equation. We subtract 7 from both sides, giving us 138 equals 6x. Then we divide by 6 on both sides to get x equals 23, I believe. Let me just double check. Yes. But we aren't looking to solve for x. We're not done with the problem. We had to find RWV, our blue angle here. So if RWV was originally 2x plus 10, but we know that x is 23, we just have to plug in 23 here. 2 times 23 is 46, plus 10 gives us 56 degrees. We will have to do something similar for part C here. This time we have another bisection. RA bisects our angle, cuts it in half. URA is this side of the angle. There we go. And ARS is the other side of the angle that I'll mark in blue. Well, what do we know about an angle that's been bisected? We know that both of these sides, we don't know what angle measure they have, but both of these sides have to have the same measure. This means that we can set this side, URA, equal to ARS. Negative 4x plus 33 equals 2x plus 81. Let's start by moving the x onto one side. I'll add 4x to both sides, giving us 33 equals 6x plus 81. Then I'll subtract 81 from both sides, giving us negative 48 equals 6x. Then I'll divide by 6 on both sides to get x equals negative 8. You might say, Mr. Strager, it's not possible for an angle to be negative. You're right, we're not talking about our angles here. This is just our unknown value that we'll have to plug in. So we're trying to find the measure of angle URS. URS is the entire big angle here. So we will need to figure out how big this side is and how big this side is. The good news is we don't need to do the math twice. Because our angle is being bisected, we know that it has to be the same on both sides. So when we plug in negative 8 for just one of these, I'll plug it in on this one. Negative 4 times negative 8 plus 33. Whatever answer we get is going to be the same as the answer on the other side. Negative 4 times negative 8 plus 33 gives us 65 degrees for angle URA. And since the angle is bisected, we know that if we plug in negative 8 to this side, we're also going to get 65 degrees. 65 plus 65 gives us the entire angle 130. Finally, angle TAI is a straight angle. The measure of angle TAX is 5x plus 20. The measure of angle IAX is 7x minus 8. And we need to find the measure of angle TAX. Folks, this one was meant to trick you. Because we could just set this up as this plus this equals 180, because it's a straight angle, and we can use the angle addition postulate. But the diagram has something to help us. We are told that these two angles are congruent. We can solve this conceptually without the need for much math at all. What angle plus itself will equal 180? In other words, let's say I call this angle measure, I don't know, z degrees. Then this one would have to be z degrees. Z plus z has to make 180, so 2z equals 180. If we divide 180 by 2, isn't z just 90 degrees? Folks, this is just two right angles put next to each other to make 180. Measure of angle TAX is 90, because that's half of 180. All right, folks, that'll conclude our notes for today. Thank you so much for listening, and have a fantastic rest of your day.